Okay, so we need to represent a token, a user token. So we'll follow the common pattern of creating a file inside our data directory. So I will simply say touch internal data, and I will call this file tokens.go. Okay, so where is that? Okay, right here, tokens.go. So in this file, we will specify what it means to be a token. So let's just say file name, internal /data /tokens.go. Okay, so it's a part of package data, and there are a few things we need to import because we want to create a cryptographically secure pseudo-random hash. So we're going to use crypto /rand. Okay. All right. Crypto rand. Then we're going to need the SHA-256. Okay, so that's SHA-256. And we will need BS32. Okay, so encoding /BS32 because we want to convert to a BS32 value. And of course, we need time. Okay, so we need to specify, since we will be having different types of tokens, let's just create the different types. So token types, which we are calling scopes. Okay, but let me change this to types and say categories. Yeah. So I will make that a constant. And so the first one we need, we're going to call it scope activation. Okay. And so this is just another way of saying activation. All right. So later on we'll add more categories, but for now all we need is the activation token type. So let's just create a token. So we will define what it means to be a token. Define the token type. Okay. So obviously we will say type. We call it token. It will be a struct. And so this token will have a plain text field. It will have a hash field, which is a byte slice. It will have a user ID, which is an int 64. It will have expiry, which will be time, that time, and it will have, of course, the scope, which is a string. Okay, so this is what we mean by a token. Okay, so what I want to do now is to create a function that is able to create a token, okay, an instance of a token. So when we call this function, it should return to us a token. All right, so say the generate token function returns a token. Okay, and so we're going to say func generate token, and to generate the token we need to pass in the user ID, okay, which is of course int64. We need to pass in how long the token should be valid for. Let's just call it TTL, time to live, and it's of type time.duration. And of course we need to specify what type of token it represents. So let's call that scope, and that is of course a string. And so once we provide these three values as parameters, we will simply return a pointer to the newly created token and any error messages. Alright, that's straightforward. Let's actually write the code to do that. And so what I want to do, I want to create a token. Alright, that's the first step. Create a token. So we're going to use ampersand token. Okay, and we know we need to provide user ID, which will be user ID. The expiry, which will simply be, we can't just keep it as TTL. We want to say from the time it has been created until. Alright, so for example, if it's created right now, and let's say right now is 8 o'clock, if TTL is 1 minute, or let's say 1 hour, then we know that the expiry will simply be 1 hour, right? It will be 9 o'clock, which is 1 hour. And so all we have to do is to simply say time.now, okay? And then we will add TTL, and that will tell us when it will expire, okay? When our token will expire. And finally, scope will simply be scope. Okay, so that's our token. However, before we return this token, we need to actually create the cryptographically secure version of the token. All right, so it's a multi-step process, and so let's start off. So we'll create a byte slice. So I'll create a byte slice, okay, holding bytes to hold random values. Okay, it will hold random values and fill it with values from the cryptographically secure pseudo random number generator function. Okay, so that's easy enough. So I'm just going to create a variable called random bytes. Okay, it's a byte slice, so we'll use make, and we're going to say that it's of type byte, but it should be 16. Okay, size 16. Great. And so now let's fill it with some random bytes. And so to do that, we will simply call rand.read. Okay, and so what rand.read will do is to simply fill this byte slice with random bytes. Okay, so read is a helper function that calls read.read, and it returns random values. That's all it does. Okay, but notice it can return an error. So let's just check for the error. So if error not nil, then we know that we have a problem. So we'll return nil, signifying that we did not create a token, okay, along with an error. Okay, So assuming that we have filled our random byte slice with some random values, then we can proceed to the next step, and we actually encode the values in random bytes using BS32 encoding. Okay, so we need to make sure that our token is secure. So we will simply we will encode the byte slice to a BS32 encoded string. Okay, so how do you encode a string to a BS32 encoding? Well, we can simply call the function to do that. So we're going to say token.plaintext, and in here we will store our encoded string. So we'll say bs32.std encoding. Okay. But before I do that, I will say dot, and I will say with padding, and I will say bs32.no padding. So Go will automatically pad with a padding value, but in this case I don't want any padding to occur. Okay. Alright, and so we'll encode to string. That's it, and just pass in random bytes. Okay, so this will generate a base32 encoding of this byte slice that we passed in. Okay, so this will be the string that we will send to the user via the email. Okay, that's the encoding for them. However, we need to make sure we hash this string and store that in our database. And of course, if you recall, we never store the plain text version in our database tables. We always store the hash version. So if anybody gains access to our database, they cannot see valid tokens that they can use for users. Okay, they will only see a hash. Okay, so let's just hash the string token. Okay, and again, Go provides us with ways to hash. So we'll simply say hash is SHA-3256. Okay, that's sum 256. Okay, and then we will simply provide that string. Okay, where is it? It's called token.plain text. Okay, so this hash is the hash version of this plain text 32 base 32 encoding. All right, so I will simply say token that hash will be assigned our hash. However, we have a slight problem because Go does it for us, right? So hash is an array. Okay, it's an array, right? It returns an array. Okay, but we want to store a slice. Okay, a slice. All right, so we need to convert the array, convert this array to a slice, and to do that we use this operation, right? But Go did that for us automatically. All right, so with that out of the way, we can now return the token, and since there are no errors, we return nil. And that is how we create a token. All right, great. So I'll leave it here. And so the next step, and you can probably guess the next step, we have to create our model so that we are able to interact with our database. Just like similar to how we created models for users and for schools, we need to create a model for tokens so that we can actually write a row of data to our tokens table. All right, I'll see you in that video where we'll jump into doing just that. I'll see you later.